They found footprints, dozens of them, fossilized in stone, walking side by side. But here's what made paleontologists stop cold. They weren't from the same species. Different dinosaurs, different bodies, different defenses walking together like a herd. And then they found the predators, two massive tyrannosaurs tracking them, hunting them. This is the first evidence of mixed species herding behavior ever found in dinosaurs. And what it reveals about survival 76 million years ago will change everything you thought you knew about these animals. Dinosaur Provincial Park, Alberta, Canada, one of the most famous fossil sites on planet Earth. For more than a century, paleontologists have pulled thousands upon thousands of bones from this place. Massive skeletons, predator skulls, herbivore remains. Some of scientists have been digging here since the early 1900s. Every square meter surveyed, mapped in excruciating detail, studied, published in hundreds of scientific papers spanning generations of researchers. Bones dominated the entire narrative for over 100 years. Skeletons told scientists what these animals looked like, how massive they were, what they ate, how they evolved, what killed them. This site became so thoroughly understood, so exhaustively documented, scientists believed they knew everything it could possibly tell them. Every secret extracted, every bone catalogued. Until July 2024, when an international research team stumbled onto something that had been walked past, overlooked, ignored for over 100 years. Not bones, footprints. And not just any footprints, these tracks told a story bones never could. Dr. Phil Bell noticed it first. He'd been working excavations in Dinosaur Provincial Park for nearly 20 years. Bones, always bones. He'd never given footprints much thought because geological conditions here don't usually preserve them. But this rim of exposed rock looked wrong. The texture wasn't smooth erosion carved by wind and water over millennia. It wasn't random cracking from geological pressure. It looked biological. It looked like mud that had been stepped on, compressed, squelched out between toes, then frozen solid, turned to stone. He called in the team, and what happened next would rewrite our understanding of dinosaur social behavior. They excavated 29 square meters, methodically, photographing every centimeter, measuring every single depression, documenting angles, depths, spacing with scientific precision. And what emerged from that ancient mudstone wasn't a single animal that had passed through alone 76 million years ago. It was a group. 13 footprints clear as day, representing at least 5 separate individual animals, all moving in exactly the same direction, side by side in formation. Ceratopsians, horned dinosaurs, relatives of Triceratops, herbivores built like living tanks, horns for goring, bony frills protecting necks, animals that could absolutely fight back when cornered. The spacing between tracks was consistent, not random, the direction perfectly aligned, not coincidence. These animals were deliberately moving together as a coordinated unit. But then researchers noticed something that changed everything, right there among the Ceratopsian tracks. A different footprint, smaller, completely different shape, different structure, different gait pattern. Not a ceratopsian, an ankylosaurid, an armored dinosaur, built like a prehistoric tank, body covered entirely in thick bony plates, tail ending in a massive club capable of shattering bone with a single swing. Two completely different species, different bodies, different defenses, different evolutionary histories walking together in the same direction, at the same moment in time in formation. This wasn't animals randomly crossing paths hours or days apart. This wasn't coincidence. This was deliberate coordination. This was social behavior. This was herding. Mixed species herding exists in nature today, but it's rare, and it only happens for very specific survival reasons. On the African savanna, wildebeest and zebra travel together constantly. Different species, different diets. Wildebeest eat shorter grasses, zebra eat taller grasses. They're not competing for the same food, but they share something far more important. Zebras have better eyesight. They spot distant movement faster, predators on the horizon, threats approaching from miles away. Wildebeest have better hearing. They detect sounds zebras miss entirely, rustling in tall grass, stalking predators, danger approaching from behind. Together, they detect threats faster than either species could possibly achieve alone. More eyes constantly watching for danger. More ears listening for sounds that don't belong. Different sensory abilities covering each other's perceptual blind spots completely. And when predators attack, the sheer size and diversity of the mixed herd makes it exponentially harder to single out one vulnerable target. Confusion, numbers, coordinated defense, survival through cooperation. 76 million years ago, on what would one day become Alberta, Canada, The exact same survival strategy was being deployed by completely different animals. Ceratopsians, fast, agile when they needed to be, armed with horns capable of killing, frills providing neck protection but fundamentally vulnerable to ambush if isolated, if caught alone, if surprised. Ankylosaurids, slow, ponderous, but covered head to tail in thick bony armor plates, nearly invincible from above. Tail club delivering devastating defensive strikes, but if they didn't see danger coming, if they got surprised, if faster predators flanked them, they were in serious trouble. Together, walking side by side, they covered each other's critical weaknesses perfectly. The ceratopsians detected danger early with better mobility and vigilance. The ankylosaurid provided a nearly impenetrable mobile fortress if the herd got attacked. Predators had to get through armor to reach the more vulnerable ceratopsians, and that gave the entire group time to organize defense. This wasn't about any individual animal being the strongest, the fastest, or the most well-armed. This was about not being alone. Safety wasn't individual, it was collective. And then the researchers found something that transformed this discovery from fascinating to absolutely chilling. Two more tracks, much larger than anything they'd found so far, deeper impressions showing immense weight pressing into ancient mud, three-toed, unmistakable predator morphology. Tyrannosaurs, apex predators, some of the most powerful, most dangerous carnivores ever to walk planet Earth. Animals that could bite through bone, crush skulls, kill with single strikes. But here's what made every paleontologist's blood run cold. The Tyrannosaur tracks weren't random, they weren't scattered. They were side by side, walking together, moving perpendicular to the herd at a 90-degree angle. Not running, not sprinting in pursuit, not charging in panic, walking methodically, deliberately, patiently, crossing the exact path the mixed herd had taken. The spacing between the Tyrannosaur tracks proves they were walking together, coordinated. The angle of their path compared to the herbivore tracks suggests they were tracking the herd, following, watching, assessing from a distance. Maybe positioning themselves to cut off escape routes, maybe flanking from different angles, maybe coordinating an attack strategy the way modern wolves hunt elk. Dr. Phil Bell described it perfectly. Quote, "The Tyrannosaur tracks give the sense that they were really eyeing up the herd, which is a pretty chilling thought. But here's the haunting part, we don't know what happened next. There's no sign of panic in the herbivore tracks, no sudden direction changes, no scrambling, no chaotic scatter pattern you'd expect if predators attacked, no evidence of violent struggle. Did the predators actually attack the herd? Did the herbivores detect the tyrannosaurs in time and escape? Did they stand and fight collectively, using their numbers and mixed defenses to drive predators away? Or were the tyrannosaurs simply following a scent trail hours after the herd passed, never actually encountering the living animals at all? The tracks captured a moment of incredible tension. Predators and prey, hunters and hunted, the evolutionary arms race frozen in stone, but they didn't capture the ending. We have the setup, we don't have the resolution. Dinosaur Provincial Park has been systematically excavated for over 100 years. Thousands upon thousands of bones meticulously recovered, studied, cataloged, displayed in museums worldwide. Those bones tell us what dinosaurs looked like. Size, proportions, diet inferred from teeth, growth rates from bone histology, evolutionary relationships traced through skeletal anatomy. But bones don't show behavior. They don't show interaction between living animals. They don't show who traveled with whom. They don't show social structure, coordination, cooperative strategies. Tracks do. Tracks preserve moments that bones never can. Direction of travel, speed of movement, group spacing, species association, perfect timing synchronization. This track site doesn't just prove dinosaurs walked. Every fossil proves that. This site proves they walked together, different species, deliberately coordinated, moving as a defensive unit across a dangerous landscape. And this site is only partially excavated. The tracks continue deeper into the hillside. More animals, more interactions, more moments of prehistoric life still buried beneath sediment. Dr. Brian Pickles, one of the lead researchers, explained, quote, "Using the new search images for these footprints, we've been able to discover several more track sites within the varied terrain of the park. Multiple track sites, not one isolated event. A pattern. This wasn't rare. This wasn't a fluke. Mixed species herding wasn't accidental. It was a deliberate survival strategy deployed regularly by multiple groups of dinosaurs across this entire region." Claiming mixed species herding is an extraordinary claim, and extraordinary claims require extraordinary evidence. Scientists couldn't just look at tracks and guess. They had to systematically eliminate every alternative explanation. First critical question, timing. Are these tracks actually from the same moment in time, or did different animals pass through this area hours, days, weeks, or even years apart, leaving tracks that only look coordinated? Answer: all tracks formed in the exact same mud layer. Same sediment composition, same hardness, same preservation state. They weren't separated by intervening sediment deposits. They were made within minutes or hours of each other maximum, not days, definitely not weeks or years. Second question: direction. Were these animals actually moving together, or just randomly crossing paths from different directions at different times? Answer: the tracks aligned parallel within minimal margin of error. Same direction, same heading, not random crossings from perpendicular paths, coordinated movement, formation travel. Third question: spacing. Were they just coincidentally near each other, or actively maintaining group cohesion the way modern herding animals do? Answer: the spacing between tracks is remarkably consistent. They weren't wandering randomly in roughly the same area. They were maintaining deliberate formation, staying together, coordinating spacing the way modern herd animals maintain safe distances while traveling. Fourth question: species identification. Can we be absolutely certain these tracks represent genuinely different species, not just different ages, different sexes, or different-sized individuals of the same species? Answer: the track shapes are completely fundamentally different. Different foot structures, different toe arrangements, different gaits, different weight distributions, different anatomical proportions. These are unquestionably, definitively different species. Every single finding was published in PLOS One, one of the most respected peer-reviewed scientific journals in the world. Independent experts who weren't part of the original discovery team challenged every conclusion, tested every interpretation, verified every measurement. This isn't speculation. This isn't interpretation stretching evidence too far. This is rigorously documented, independently verified, peer-reviewed scientific evidence. But even with all this evidence, major questions remain unanswered. The tracksite is only partially excavated, and the tracks we can see raise haunting questions that may never be fully resolved. How common was mixed-species herding? Multiple tracksites suggest it wasn't rare. But was this normal daily behavior happening constantly, or occasional defensive responses to specific high-threat situations? Did tyrannosaurs actually hunt cooperatively? Were they coordinating sophisticated pack attacks the way modern wolves systematically take down elk? Or were they just two solitary individuals who happened to be following the same scent trail independently? Modern predators show both strategies. Wolves hunt as coordinated packs with assigned roles. Tigers hunt entirely alone. Lions form prides, but individuals often hunt solo, which behavior pattern matched tyrannosaurs. And the question that haunts this site most deeply: did the tyrannosaurs actually attack the herd? Did the mixed species group detect the predators in time? Did they stand and fight using coordinated defense? Did they run? Or did the predators assess the herd, recognize it was too large, too alert, too well coordinated to risk attacking, and simply move on searching for easier isolated prey? The tracks preserve one frozen moment from 76 million years ago, a moment of incredible tension, predators and prey sharing the same ancient landscape, but they don't tell us how the story ended. We have the setup, we'll never know the resolution. This discovery accomplishes something profound that extends far beyond one tracksite in Canada. It fundamentally proves that social complexity, the sophisticated behavioral strategies we see operating in modern animal populations today, existed 76 million years ago. The survival strategies that work on African plains today worked in the late Cretaceous period. Different species recognizing mutual survival benefit, coordinating movement across species boundaries, sharing vigilance responsibility, collective defense against shared threats. For too long, dinosaurs were culturally imagined as solitary monsters, lone predators stalking landscapes, isolated herbivores grazing separately, creatures driven purely by simple instinct with no complex social structure, no communication, no coordination. This tracksite completely shatters that outdated image. These animals were coordinating movement across species, communicating danger somehow, making sophisticated decisions about who to travel with and exactly why. Social behavior isn't new, it isn't modern, it isn't uniquely mammalian. It's ancient, deeply ancient. And it worked 76 million years ago for exactly the same reason it works today in modern ecosystems. Survival is easier together. That truth transcends species. It transcends time, it transcends evolution itself. 76 million years ago, a mixed herd of dinosaurs walked across wet mud near what would one day become Alberta, Canada. Ceratopsians and at least one ankylosaurid, moving together deliberately through a world absolutely filled with lethal danger. Somewhere nearby, two tyrannosaurs crossed their path. Whether they attacked, we'll genuinely never know. Whether the herd detected them in time and escaped, we'll never know. Whether they stood and fought collectively, we'll never know. But the mud hardened around their footprints. Sediment slowly buried the surface. Geological pressure transformed soft mud into solid stone, and the moment survived intact through 76 million years of planetary change. Today, scientists walk carefully in those exact same footprints, measuring, documenting, recording, trying desperately to understand not just what these animals looked like, but how they actually lived, how they thought, how they communicated, how they survived together. Sometimes the ancient past doesn't speak to us in words or symbols. Sometimes it speaks in footprints pressed into stone. And those footprints tell stories that bones scattered across museum drawers never possibly could. The tracks are still there, waiting, partially excavated, partially buried. And with every careful measurement, every detailed photograph, every scientific publication, they remind us of something humbling. We're only beginning to understand the behavioral complexity of the world that existed before us. If you want more discoveries like this, where ancient fossils reveal living behavior, not just dead anatomy, hit subscribe. Because the most fascinating stories from deep time are still being uncovered, right now, today. Every story here is built on what the evidence actually shows, not speculation, evidence.